Welcome to Cannizzaro reaction. In this video, I'll walk you through the reaction mechanism, the flow chart, how to do extractions, and then we'll do the whole experiment in lab. Let's begin with the balanced equation. We have 4-chlorobenzaldehyde reacting to make 4-chlorobenzoic acid and 4-chlorobenzyl alcohol. This is a unique reaction because we have two different products with different functional groups. Let's walk through the reaction mechanism. A hydroxide ion attacks the carbonyl carbon, bringing up the electrons to the oxygen. Then those electrons come back down, and the hydrogen can act as a leaving group, attacking the carbonyl carbon on the other molecule. This is considered the hydride transfer. Then we have a simple acid-base reaction resulting in our two products. The carboxylic acid ion is oxidized and the alcohol is the reduced product. Notice that this is an ion in solution, so it will stay in the aqueous layer, while this will stay in the organic layer. Let's run through the flowchart. I want to underline that this is after the reaction. This flowchart is critical for you to do well in lab. After the reaction, we'll add 2 milliliters of water, which will result in two layers, an aqueous layer and an organic layer. In our organic layer, we'll have our alcohol, and in the aqueous layer, we'll have our deprotonated acid. We'll extract the top layer using methylene chloride as our solvent. Let's briefly talk about solvents and extraction to understand this step better. In lab, we'll commonly use diethyl ether and dichloromethane as solvents. Diethyl ether is less dense in water, so it's going to be above the aqueous layer, which is 1 gram per milliliter. Dichloromethane is more dense in water at about 1.3 grams per milliliter, so it's going to be below the aqueous layer. If we have all three layers, we would have diethyl ether, water, and dichloromethane. In the Cannizzaro reaction, we'll be using dichloromethane, so our organic layer will be at the bottom. Now let's talk a little bit about extraction. If we have an aqueous layer with a few organic molecules, we can take those out by adding an immiscible solvent. In this case, it could be something like diethyl ether. We shake the layers together and we obtain the organic compound in the organic layer. When we extract with methylene chloride, we take out the bottom layer. That will have our alcohol. That will be the organic layer. Then we can simply evaporate that, and we're left with our crude alcohol product, and it's a white solid. With our acid, we can't simply evaporate the water. We have to add strong acid to protonate the acid molecule and precipitate it out of solution. After that, we can filter it through a Hirsch funnel, and then we've obtained our crude acid product, which is also a white solid. Now let's go into lab. Here we have a 5 milliliter conical vial and a large spin vane. We have an aluminum heating block to heat it up evenly, and this is fitted with a water condenser, water coming in here, and water coming out here. We have weighed out 150 milligrams of 4-chlorobenzaldehyde. We remove the water condenser and place the 4-chlorobenzaldehyde into the conical vial. Now we'll add 400 microliters of methanol to the conical vial. And 400 microliters of 11 molar potassium hydroxide. We want to make sure to keep this bottle in the ventilation hood at all times. The potassium hydroxide is then added into the conical vial. The water source for the water condenser is then turned on slightly. The reaction mixture is heated and stirred at reflux for 1 hour. After 1 hour of reflux, we allow the reaction mixture to cool down to room temperature. Before extraction, we add 2 milliliters of distilled water. Now I'll use methylene chloride to extract 3 times. We'll put a lid on the conical vial, and then we'll shake it up to mix both layers together. The bottom layer contains our alcohol, and the top layer contains the carboxylic acid. We'll take out the bottom layer and place it in a separate conical vial. We'll repeat this procedure 2 more times. Make sure to keep both the organic and aqueous layers. We'll begin with the isolation of the alcohol, which is the bottom layer. We'll do saturated sodium bicarbonate solution washes to remove any base that may have followed along with the methylene chloride. Since water is less dense than methylene chloride, we can discard the top layer. We follow this procedure one more time. The sodium bicarbonate washes can now be discarded in the aqueous waste. Now we'll dry the methylene chloride using desiccant. We'll first place it in a small Erlenmeyer flask, and then add sodium sulfate until it is free-flowing. Notice how there are still large clumps, so we need to add a little bit more. Now you can notice smaller particles free-flowing. Using a pressure pipette, we take the methylene chloride and put it into a new conical vial. Using a gentle stream of air, we evaporate the methylene chloride until we're left with our crude alcohol product. We will now recrystallize the alcohol. You can watch the recrystallization technique video to watch a more detailed version of this. We begin by placing the alcohol in a small test tube. A small test tube provides enough surface area for proper recrystallization of the alcohol. Lagroin is used as the solvent to recrystallize alcohol. We'll place Lagroin in a separate test tube and place it in boiling water. Then transfer the minimum amount of hot Lagroin needed to dissolve the alcohol. The test tube is placed in ice-cold water to test for precipitation. If it does not precipitate, you will need to boil off excess solvent. Once it has successfully precipitated, you can dissolve it in the boiling water and recrystallize at room temperature. Once it has recrystallized, you can filter it using the Hirsch funnel. We can now weigh our pure product. At this point, we can begin characterizing our product by obtaining a melting point and a neutral mole IR. The melting point can be obtained using an open-closed capillary tube and a small amount of product. Then agitate the product towards the closed end. The literature melting point of the alcohol is 72 degrees Celsius, so we'll start ramping up a little below that. Record the correct melting point range. Since we have a solid product, we will use the neutral mole technique to obtain an IR. Please watch the neutral mole technique video to see this in more detail. We begin by adding some of the solid to one of the salt plates and a drop of neutral. We place both salt plates together until we have a milky suspension. Place both salt plates into the IR machine and run the IR. We have the alcohol peak right here and some of the benzene peaks right here. Now we'll move on to isolating the acid from the aqueous layer. We'll begin by adding some distilled water to dilute the solution. Now we're going to add concentrated hydrochloric acid. Remember to carefully handle the solution with gloves and in the ventilation hood. The acid will free the 4-chlorobenzoic acid from the potassium ion, resulting in a slurry of the carboxylic acid in water. If the slurry dissolves, that means you need to add more acid. Now use the Hershey funnel to filter your crude product. We will use the same recrystallization technique, except we will recrystallize with ethanol instead of Lagroin. Place your product in a small test tube. Place ethanol in a separate test tube and heat it up in boiling water for a few seconds. Then use the minimum amount of hot ethanol to dissolve your product. Once it is dissolved, place it in ice-cold water to test for precipitation. Once it precipitates, you can use the boiling hot water to dissolve it again. And now let it recrystallize at room temperature. After 5 or 10 minutes, you can place it in ice-cold water to obtain any last formations, and then filter it using the Hirsch funnel. The test tube can be rinsed with ice-cold water to obtain as much product as possible. Now we are ready to weigh the product and characterize it. It weighs 25 milligrams. We will take a melting point using the same method as the alcohol. The literature melting point of the acid is 241 degrees Celsius, so we'll start a little bit below that. Record the correct melting point range. Now we'll take an IR using the neutral mole technique. We'll place some of the solid on one of the salt plates, and then a drop of neutral. Put both salt plates together until you get a milky suspension. Place both salt plates into the IR machine and run the IR. We may have added a lot of neutral, but we have our carboxylic acid peak and our carbonyl peak.